Good afternoon to all. I'm Arafat. My topic is effect of molybdenum nanoparticles on lead-free tin-based solder. So, as semiconductor devices are getting smaller, faster, and more powerful, packaging of electronic devices becoming a performance and reliability limiting factor. Previously, lead-tin solder is now being replaced by lead-free solder because lead is one of the most harmful elements for human body, and it contaminates the soil, water, and attacks the ecosystem. So, in 2000, the National Electronic Manufacturing Initiative suggested to use electric tin, silver, and copper, that is SSC solder alloy, as a replacement of lead-tin solder. But this solder alloy cannot guarantee the required performance and final pitches due to demands such as high diffusivity and softening nature of the solder. And so far, no alternative have been found for lead-tin solder, and especially in the case for high temperature, for example in power electronics and automotives. So my objective in my research is to develop a nanocomposite solder having better thermal stability in terms of properties and microstructure. So for this reason, nanocomposite solder containing molybdenum nanoparticles were prepared by using cyclical test mixing method in extensive microstructural investigations such as PDX, SEM, TEM, high temperature exposure test was done on the nanocomposite solder, and it is found that molybdenum nanoparticle added SEC solder produces finer bulk as well as interfacial microstructures and have better thermal stabilities. It is found that molybdenum addition to the solder produces lower dissolution rate of the copper substrate, suppresses the 6-5 IMC during reflow and high temperature aging, and produces smaller scallops, lower the diffusion coefficients, and it is found that the mechanical properties is improved, for example the micro hardness. So it is found that the top surface of the exposure of the top surface of interfacial IMC found that the molybdenum nanoparticles do not go any kind of dissolution or reaction and preferentially absorb at the grain boundaries and block the channels for substrate dissolution. So it can be said that the molybdenum nanoparticle added SEC solder has less fit for interfacial reaction, which in turn produces smaller IMC scale. So finally, it can be said that addition of molybdenum nanoparticles to the solder produces smaller IMC thickness and IMC scallops, which are desired in the electronic industries, and for this reason it can be said that molybdenum nanoparticle added SEC solder has good industrial implication. That's it. Thank you.